Today, Mars is an arid, irradiated rock suspended in the vacuum of space. It is a freezing desert where liquid water cannot survive. Drop down into Jezero crater, and the reality of that harsh environment becomes immediately clear. The landscape is desolate, covered in rusty dust and wind-scoured rock. This false-color topographic map shows the exact reason NASA sent a multi-billion-dollar rover to this specific crater. You can clearly see a fan-shaped river delta carved directly into the surface, proving that abundant water once flowed here. Based on the size and structure of those visible surface channels, planetary geologists calculated that this delta actively hosted flowing water roughly 3.7 billion years ago. Those surface features provide physical evidence of a wet past, but they represent only the final chapter of Mars's watery history. The modern Martian surface is incredibly hostile. Temperatures regularly drop to minus 150 degrees Fahrenheit, and without a thick atmosphere or magnetic field, the ground is bombarded by intense cosmic radiation. This combination of deep freeze, high radiation, and relentless erosion destroys complex organic molecules. The environment aggressively breaks down any biological material left on the surface. When hunting for ancient life, astrobiologists follow a specific rule: follow the water. Searching strictly on the exposed surface means looking in a zone where the environment has likely already erased any ancient biosignatures. To bypass that destroyed surface layer, researchers targeted a specific geological area within Jezero crater, known as the margin unit. The margin unit drew attention because it is highly concentrated with carbonates. Carbonates are minerals that typically form in stable liquid water environments, and they are excellent at trapping organic material. To investigate what lay beneath these minerals, the Perseverance rover utilized its RIMFAX instrument. RIMFAX is a ground-penetrating radar system that uses radio waves to map structures buried deep beneath the dirt. Over several months, the rover conducted 78 traverses across 6 kilometers. As it rolled, it fired radar waves into the bedrock. By recording bouncing radar echoes, scientists mapped unseen stratigraphy down to 35 meters. Stratigraphy is the study of rock layers and their deposition order. The rover was effectively X-raying the planet's past, bypassing the irradiated danger zone to look at pristine geology. Hidden in that radar data was a massive, distinct river system, buried directly beneath the visible surface delta. The scans revealed distinct clinoforms, sloping sediment layers that form when rivers deposit sand into standing water. This structure is 90 meters thick. Researchers date it that 4.2 billion years to the Noachian period, an era characterized by abundant surface water. This underground structure proves that liquid water was actively shaping the planet 500 million years earlier than the surface evidence implied. Previous scientific consensus suggested that liquid water on Mars existed only during a relatively brief window. This buried delta indicates that those wet conditions persisted for hundreds of millions of years longer than once thought. Mars experienced a dynamic history, with multiple extended phases of flowing rivers and sediment deposition. Because this earlier river system is buried beneath dozens of meters of rock, it is shielded from the radiation on the surface. That rock acts as an impenetrable shield. Deposited during the planet's wettest era and then buried, this delta provides the exact conditions needed to preserve ancient biosignatures. Perseverance is currently drilling into these ancient, protected layers, collecting samples and sealing them in titanium tubes. The mission objective is to retrieve these specific underground samples and launch them back to Earth for rigorous laboratory analysis. Evidence of ancient life may not be found on the maps of the surface, but in the layers of sediment preserved deep underground.